Okay, students, welcome to school on a snow day. Technology's great, isn't it? Okay. Some of you, my students, of course, did the whole worksheet, so I'm going to go over the entire worksheet and all the problems. If you're in Miss Grigsby's class or Miss Serrano's class, you may not have been assigned the whole worksheet. So what I'm going to do is before each section, I'm going to explain what you need to do, and I'll probably even do one example. So those students who did not get assigned the entire worksheet, you should listen to my directions when you get to a section that you haven't done, and then pause the video, try the section problem by problem, and then run the video. If you still can't figure it out, watch as I do the first one or perhaps the first two problems, and then pause the video again, finish that section, and then run the video. And that way you'll learn it. Okay? At the end of the video, I am going to assign homework to my students, Mrs. Grigsby students and Miss Serrano students. You should go to your backpack and look at what they've assigned, or they may have already assigned it for you. I'm not sure. So don't go, don't listen to my final directions. Just go look to see what's due for you either tomorrow or Thursday whenever we get back to school. Okay, so part one, we have to look at the angle that's indicated, and then we have to determine what is the opposite, adjacent, and hypotenuse. And we're going to be doing this exercise even as we get to the harder problems. So every problem we're going to have to do this. So this is the most basic thing that we learned earlier in the week. Okay, now remember, here's the angle symbol. We're going to be using this angle. Okay? So the first thing you should do is always mark the hypotenuse. The reason for that is once we lock in the hypotenuse, we can't mess that up and use it as the adjacent or the opposite by mistake, for example. Okay? So to find the hypotenuse, the H, right, every single time, just look to the right angle. And remember, we've said this before, the right angle looks like a giant arrow. It looks like the beginning of an arrow. See that arrow? And wherever that's pointing to, that's the side that's the H. So there's the H. Okay? Next, what is the adjacent and what is the opposite? And that's the more confusing part. So what I taught my students to do, if you're stuck with this, or just learning this for the first time, is take your highlighter, go to the angle, all right? Actually, I'll use the green here. We'll go to the angle. Here's the angle. And we're going to highlight the two sides of the angle. Remember that the angle is made up of two rays. Here's the first one. Actually, this is a segment, right? But the ray would keep going forever in this direction, okay? And this ray, right? It's the separation of two, often two segments, as we're doing here. Officially, technically, it's two rays that go on forever. Okay, so there are the two sides of the angle. Notice that this side over here, I'll highlight this in yellow, is not a side of the angle. Okay, that's not the side of an angle, of this angle. It's the side of this angle up here, right? So if we were looking for the opposite and adjacent to that angle, that would be the adjacent, okay? But when we have this angle here, one of the sides is going to be the H, but one is going to be the A. Okay, so the adjacent, the A, the adjacent is, which means next to, right? Next door, if you want to think of that. Next to, right? Next to. Adjacent means next to. So the next to is always going to be the side of an angle. Well, the H was already taken. I can't use that side of the angle, so I know it has to be this side. Okay, and then the opposite is the far side, right? The side not touching it. So if you look at the angle's kind of facing and pointing this way, see? That's the opposite side to the angle. It's far away from the angle. The adjacent is close to the angle, and the H is always the H. Okay, I'm going to go a little bit faster now. So for this problem, here's our angle. I will use the highlighter for a first couple times. Here are the two sides of my angle. There they are. I know that one of them is the H. I got to do the H first. The H is across from this angle there. That's the H. And you can see it's the longest side, right? Physically, it's always the hypotenuse, the longest side. So on the blue sides here, this must be A, because A has to be one of the sides of the angle, and I already used the other one for H, which makes this the opposite, okay? Here's my angle. There's the right angle, so this is the hypotenuse. This is the adjacent. It's the other side of the angle, right? Here's the two sides. So this must be opposite. Okay, here's my angle. The hypotenuse is here, across from the right angle, across from the right angle. This must be A, which is next to the angle. This must be O, which is across from the angle. Okay, I'm going kind of fast. I may make a mistake. Usually in every video I make one mistake because I'm rushing a little bit so I can get a lot done for you. If that happens, just ask your teacher next time you go back to class, and we'll certainly point out mistakes for you. Okay, right angle here. This is the hypotenuse. This is the adjacent. This is the opposite. Okay. Here's the angle. Here's the right angle. The right angle is across from the hypotenuse. The other side of this angle, this side, there it is. That's the side, right? Has to be the A, so this has to be the O. Okay. I know I'm going out of order a little bit. 4, this is the hypotenuse across from the right angle. This is the adjacent, and this is the opposite. Okay, for this angle here, we know this is the hypotenuse across from the right angle. This is the adjacent, and this is the opposite. Sorry, that's 10 actually. So back to 5. This is the hypotenuse. This is the adjacent. It's next to this angle. And of course, the opposite is far away from the angle. See? This is the angle here. This is the hypotenuse, of course, across from the right angle. This is the adjacent. This is the opposite. Okay? This is the angle. There's 2 sides of the angle. This is the hypotenuse. We always do the H first. Always do the H first. Adjacent is the other side. Here's my 2 sides of the angle. I know some teachers, and I've used this too, it looks like a crocodile, right? So, you know, a crocodile has a mouth like this. Terrible looking crocodile. It's not even very fearsome. Teeth, right? There it is. So the angle is like the mouth of a crocodile. See, this is like a mouth of a crocodile. Okay? That's theta. Okay, last one here. This is H. This is the angle. This must be the adjacent, and this must be the opposite. Okay? All right, let's go to number 2. So number 2, what we're going to do is we're going to write a trigonometric ratio. Now, you should know SOH-CAH-TOA, right, which is sine equals opposite over hypotenuse, right? So cosine, I don't like to write the equals here, but I'm doing it, so I'm going to do it. Adjacent over hypotenuse, because you really need cosine of an angle, right? So the sine of an angle equals the opposite over the hypotenuse. The cosine of an angle equals the adjacent over hypotenuse, but I'm just trying to show you the SOH-CAH-TOA to help you memorize it, right? And TOA is opposite over adjacent, right? Really, it should be written like this. Sine of some angle, theta, or x, you could put x there too, is equal to the opposite leg over the hypotenuse, right? Okay, but you get the idea. You have these in your notes already, I know, so make sure you keep them handy. Okay, so they're asking us for the sine of theta. Here's theta. So I need the opposite and the hypotenuse. Well, let's label everything like we always do. This is H. Here's the angle here. So this is A, that's the adjacent, and this is the opposite, okay? All right, so they want opposite over hypotenuse. So it's 1/2, that's the opposite length, over the hypotenuse, 1. So anything divided by 1 is itself. So this is just 1/2. Okay, over here, cosine of theta. So here's theta. Here's my hypotenuse. Here's my adjacent, here's my opposite, right? Because remember, this is the angle, there's one of the sides, here's the other side, okay? All right, they want the cosine. Well, the cosine is the adjacent over the hypotenuse. So the cosine of an angle, of this angle, is the adjacent leg, 3, over the hypotenuse, which, sorry, it's 5. See, I told you I'd make a mistake. 3 over the hypotenuse, which is 5. Okay, number 2, tangent. Now, tangent is the opposite over the adjacent. So here's the angle. The opposite is here, and the adjacent is here. And remember, this is the hypotenuse. Okay, so it's 2 over 1, which is just 2. So technically 2 is the right answer, not 2 over 1, but that's pretty close. Okay, number 8, the first one we have to rationalize here. Sine of theta. So here's theta. So it's the opposite. That's the opposite, right? Far away. Over the hypotenuse. Here's the hypotenuse, radical 17. So it's 4 over radical 17. Now that's the correct answer, and I'd rather you have this than the wrong answer. But in order to get this in the right form, we have to rationalize. And you could always put the original answer and your final answer in the calculator to make sure. Over 17. And that's it, okay? Now, what you should do when you do these problems, a lot of my students got these wrong during homework, and that's okay to make mistakes. But what you should have done, at least, is put that in the calculator and put this in your calculator. Now, if you had a different answer, put your different answer in the calculator, right? And if you plug this in the calculator very carefully, making sure the radical that you hit enter, like for example, 4 times square root of 17, enter, then divide by 17, you should get the exact same numerical value, some long decimal. Okay, if you did, then that means you didn't change the value, you just changed the form, which is good. If you didn't, go back and try it again. Okay, so 4 radical 17 over 17. All right, let's go down to 3. Let's go down to 3. So 3 says the tangent of theta equals what? Well, it's the opposite over the adjacent, right? I'm not going to mark them anymore. At this point, you should know how to do that. Okay, cosine is the adjacent over the hypotenuse. The adjacent over the hypotenuse, okay? 8/10. Now, 8/10, of course, reduces to 4/5, so we're going to write the reduced version, okay? Sine of theta is the opposite. Opposite is across from over the hypotenuse. Hypotenuse is across from the right angle, right? So it's 2 radical 3 over 4, which reduces, right? The 2 and the 4 reduce to 1 over 2. Notice. Now, very good that I see you guys putting the 1 and the 2 here, but you don't keep the 1, right? The final answer is radical 3 over 2 because it's like 1x. We don't write 1x. We don't write 1 radical 3. Okay, tangent of theta is tangent is opposite over adjacent. So opposite to this angle is this 3, and the adjacent is the 6, which is 3 over 6, but that, of course, quickly reduces to 1/2. Okay, number 5. The cosine of theta is the adjacent over the hypotenuse, right? So it's 1/2 over 1, which is just 1/2. Cosine is the adjacent over the hypotenuse. Okay, number 11, the tangent is the opposite. That's the opposite, okay? Opposite over the adjacent, okay? Because this is the hypotenuse down here, right? You're not used to seeing the hypotenuse in the bottom, but that's definitely the hypotenuse. So it's radical 2 over 2 divided by radical 2 over 2. And you can do keep, change, flip, but you can be smarter and just say what? Anything divided by itself is always 1, no matter how complicated that other thing is. Okay, number 6. So the sine of the angle is the opposite leg, there's the opposite leg, over the hypotenuse, right? Don't confuse. The hypotenuse can never be opposite or adjacent, right? It's because it's an opposite leg or an adjacent leg. So the hypotenuse is always the hypotenuse. Only these two the 2 legs can either be adjacent or opposite, okay? So sine of theta is the opposite over the adjacent, opposite over the hypotenuse, excuse me, and it's 1/2. Okay, cosine of theta. It's the adjacent over the hypotenuse. This is the hypotenuse across from the right angle, and this is the adjacent, right, A. So it is 1 over radical 2. Now, that's the correct answer in the wrong form. We have to rationalize like we've done hundreds of times. Hopefully, you've done them hundreds of times if you've done all the homework this year and all the homework in your Algebra 1 class, which we did at the end of the year. Then you know how to rationalize very well, I'm assuming. Okay. Now, we're actually going to skip part 3 till the end of the video because part 3 is sort of a future warm-up to the next part of our unit, the next thing we're going to do. Not what we're going to do for tonight for homework, but when you get back to school, probably Thursday or Monday. But I'm going to show, so I'm going to do part 3, but I'm going to do it at the very end of the video. But I'm going to show you some common, these are student mistakes. These are actual homeworks from my students. And a lot of other students did this too, so I don't want anybody to feel bad, and certainly I didn't put anybody's name here. And it's very normal that this happens. But I want to, sometimes you can learn a lot from other students' mistakes. So I'm just going to highlight some problems here. Okay, so in part 3, one of the things you have to do is write an equation. Well, there's a key word in equation, a key part of the word equation, excuse me, which is equa, which is short for equal, and I don't see an equal sign here. Okay, every trig equation has to have an equal sign to be an equation. Okay, so these all need equal signs. Same thing happened here to this student in blue. These are all different students. Okay, that's a big mistake. It happens all the time. Make sure you learn that. Okay, now this student did a very good job here. The sine of 33 is equal to x over 15. Okay, he wrote it in the different direction. He put the sign at the end. That's fine. It's no problem at all. But see, this is not true. So we got to be really careful here. You can never have an angle equaling a ratio. It's a trig ratio. Now, actually, I'm not sure what, so I didn't copy the problem, but, so I may be wrong here, but the form is what I'm really trying to show you. So you'd have to have something like the sine of 35 equals x over 22. Or, I'm not sure, or perhaps it was cosine, or it was tangent, whatever it was. It doesn't matter what function it is. But you have to have a trig function, right? And it's sine of 35, right? Just like you might have square root of 16, see? These are functions. You're doing something to the number 35. You're signing it. Just like the number 16 here, you're square rooting it, okay? These are just examples, right? These are just examples. I'm not trying to solve those problems. Same thing here, okay? So it's not cosine equals 33, right? It's the cosine of 33. There's no equals here. You've already got one equals. You can't have two here. So the cosine of 33, or 35, I'm not sure what it's supposed to be, equals x over 15. And then, of course, same problem as up here. Okay, so these are, I just took some samples from your homework, my students, and there were a lot of others like these. I just grabbed the first ones I saw. So again, this is a very common mistake. It's okay to make it. That's part of learning, as I've told you many times, so no problem. But learn from this, both the students who did this and the students that haven't done it but might do it by mistake. Make sure you look over these mistakes and you understand with the corrections. Okay, let's go to part 4. All right, now we're getting into what we really are ultimately learning here, which is how to solve for a missing side. And then in part 5, we're going to do that, okay? So again, don't forget, Ms. Serrano and Ms. Grigsby students may not have been assigned this part 4. I'd like you to listen to what I'm going to explain, maybe even watch me do the first problem, and then pause the video. There's only 3 more problems after the first one. Pause the video and try this yourself. And my students that may have gotten this page completely wrong, I did email some of you if I spotted some big mistakes. Again, make sure you've done this on your own before you watch the whole video. Okay, so don't pause yet because I'm going to explain everything, right? And this, so 1, it says, now you pick the correct trig function, sine, cosine, or tangent, that will avoid the missing side. So I'm going to do it wrong with problem 1. That doesn't avoid the missing side, so you can see what happens. And that's okay. You're just going to keep trying, okay? In part 2, the correct trig function was picked for you, so review that part if you need to as well. So yeah, this is very similar to part 2, okay? Then write the trigonometric ratio. So some of you picked it, and this really should say the trigonometric ratio. Well, it should say the equation, right? The trig equation. So in other words, and let's do a wrong approach for problem 1, which is just trial and error here. So we want to avoid the missing side. There are 3 possible things I can do with this angle. A lot of you tried to use this angle. You called it theta up here. You weren't wrong, but you're never going to be able to solve the problem in part 5. Okay, I don't want to deal with this angle right now because I don't have enough information to deal with it anyway. I was given an angle. Whenever you're given an angle, you want to use it, okay? And that's really what we're leading up to, as I'll show you in part 5. So I'm going to deal with the 54-degree angle. So there's 3 different trig equations I can write. I'm going to write all of them, okay? So, and I'll do them in order that we learned them. So I'm going to do sine first. So the sine of 54, and I don't always write the parentheses here. It's not actually required, but it's not a bad habit to. So you remember it's sine of 54, not sin times 54. And you can't divide by 54. You can't multiply by 54 by a number. You have to do the sine of 54 first, okay? So the sine of 54 is the opposite leg, okay, that's x, over the hypotenuse. Now this is the hypotenuse here, you see? There's a big question mark here, right? So you could put a question mark or a blank here. That didn't work. Why? Because I want to avoid the missing side. I want to avoid the hypotenuse. And if you look at the 3 formulas, right? SOH-CAH-TOA, you actually can tell right away. You don't have to go through this whole process every time. Okay? What am I trying to avoid here? I'm trying to avoid the hypotenuse because I don't know h, right? This is h. I don't know h. So this formula has an h in it. That's bad. This formula has an h in it. That's bad. This formula does not. So obviously, which one do I need to use? I need to use TOA. Okay? I'll do the cosine anyway just to show you if you did it wrong or you trial and error like I'm doing. Cosine of 54 equals what? Adjacent over hypotenuse. Again, I got a question mark, see? I got a question mark. And I'm really trying to look for x. So this one's not solvable. This one actually is solvable. I could actually use this to find the hypotenuse, but that's not what they asked me for. They asked me for the x. So I really want to use an equation that's going to help me solve for x, and that's going to be tangent. So the final answer is going to be the tangent of 54 degrees, and the tangent of any angle, of course, is right here, the opposite over the adjacent. So the tangent of 54 is equal to the opposite over the adjacent. Notice this one avoided the question mark, the unknown side, okay? Because I don't need it. They don't ask me for it. They want me to find x. Once I solve for x, as I'm going to do in part 5, I can then go back and solve for the hypotenuse. I could use actually Pythagorean theorem if I wanted to. Or I could just use cosine as I showed you earlier. Okay, now this problem here. I want you to, if you saw what I did here, I want you to do the same thing here. I want you to use the 27 degree. I want you to try all 3 trig functions and see which one, a trig equation with the equal sign and the ratio. Find out which one and write the one that does not use this blank side, this question mark. Okay, go ahead, pause the video, try the next 3 problems, and then restart the video again. Okay, so hopefully you noticed that you have the h as the unknown again, just like before. So the only choice is going to be tangent. Okay, we don't want to use the h. There's h, there's h. Can't use those 2 equations. Okay, so the tangent of 27 equals 5 over x. Okay, when we go to solve these, by the way, these 2 problems, this is the easy one. So in part 5, this is what we're going to do. And this is the hard one, right? This is the difficult one. This is the easy one. That's the hard one because the x is in the denominator. It works fine. I'm going to teach you how to do it. But it's a little bit scarier. It's a little bit, you got to be careful when we get problems like this, okay? All right, let's go to 3 and 4, right? Write 2 trigonometric equations, one that uses x in the known side, and then a second equation that uses y in the known side, okay? All right, so we're going to use 33 degrees, okay? So we have the hypotenuse, we have the opposite, we have the adjacent, okay? So I want one that uses x. So I want an equation that uses 33, it uses 15, and it uses x. I don't want to have y in it. That would be 2 unknowns. So what equation uses the o and the h, right? That's the x and the number. And of course, that is opposite over hypotenuse, so that is sine, right? Okay, only it's not sine of theta, right? It's the 33. That is my angle. So sine of 33 degrees, okay, equals the opposite side over the hypotenuse. And this is good because that leaves me with only one variable, x. There's no other unknowns. There's no blanks. Okay? And for y, though, I need, if I don't want x at all, if I want to stick to this, I want the y value and my known value. That's adjacent and hypotenuse. Which formula has adjacent and hypotenuse in it? I hope you remembered. Okay, so cosine of 33 equals the adjacent over the hypotenuse, okay? All right, so this problem, again, if for whatever reason you haven't done any of these on your own, pause the video right now and try this. Okay, so I want x and I want 22. Well, 22 is the hypotenuse, x is the opposite side of 35, and y is the adjacent, just like in our part 1 exercise that we did. All right, well, if I want x, I'm going to use opposite, and I'm going to use the number that I know, hypotenuse. And that's going to be, just like before, sine of 35 equals the opposite leg over the hypotenuse. Okay? Only one unknown, no blanks. To get y, it's going to be cosine of 35, right? Because y is the adjacent. So it's going to be y over 22. Okay, so that, if you followed that, all we're going to do now is we're going to do the exact same thing again. And we're going to do this for homework tonight too, so we're not doing anything new. This is all the homework for tonight for all students. Is going to be based on this part 5, okay? And this is what we've been leading up to. This is the whole thing. And we call this right triangle trig. This is part type 1. Type 2 is when we have to find the angles, okay? Right now we're just finding sides. We're going to find the angles either Thursday or Monday, depending on the snow. So finding the missing sides given one angle and at least one other side, right? Otherwise we can't do it. Sometimes you're given 3 sides and you have to find the angle, or given 2 sides and you have to find the angle, okay? And of course this one angle is, not the right angle. We always know they're 90 degrees because it's a right triangle, see? This is right triangle trig. So it's one of the other angles besides the 90. The 90 is not going to help us all by itself. By the way, as you all know, if I have one angle and a right angle, I can automatically find the third angle, okay, which makes these problems very flexible. All right, so what do? We already did this last problem. We mark H, O, and A, okay? 2, find out which side you know and which side you want. So in the other problem we just did on the other page, if you want to go back, we knew, I think it was, or I'll go back. I think we knew, let's do the last problem we just did, right? We knew the 22 for the hypotenuse, and we knew the angle, right? So I knew the 22 for the hypotenuse, and I wanted x, right? If you go back to this problem here. I wanted x. Oh, I'm sorry, I'm on the wrong problem down here. I wanted x, the opposite, see? And I had 22, right? And of course I had the angle as well. But for sides, I wanted the x, the opposite, and I had the hypotenuse, okay? So that's what that means here, if you're curious. And I'll do the first problem. I'll refer back to here, okay? So, but I do want to highlight it so that it sticks out, right? You want to find out which side you know, the side you know, and which side you want. And I even translated this to Jersey speak. I am from Jersey, so I'm not making fun of anybody from Jersey, but this is how we speak in New Jersey, right? What do you got? That's one word. What do you got? And what do you want? Just please don't show this to any English teachers. They'll probably yell at me. Okay? But, you know, to be funny, I like to do that so I can remember what do I know and what do I want. Okay? And then the third step, which we already did, we did this in section 4, so if you followed along in part 4, this should be pretty easy. Write the trig equation using the trig function that matches those two sides. What do I mean by that? Well, for example, if you got O and then you wanted A, right, then you're going to look at SOH-CAH-TOA, right? SOH-CAH-TOA, right? Everybody knows what that stands for. Hopefully, I know your teachers went over this. So if you have O and A, which one of these has both O and A, right? This one has O but not A. This one has A but not O. This one has O and A, see? So if what you know and what you want is O and A, you're going to use TOA. If it's A and H, you're going to use CAH, right? Cosine. And if it's O and H, you're going to use SO for sine. All right, let's try that right here. So problem 1. Write the equation and solve for the variable. This is what we've been leading up to. The whole exercise is, well, this whole sheet really was to warm you up to this, okay? So you've got a triangle. You know one side right there, and you know one angle. You don't know the other sides. And of course, it's a right triangle. It has to be for this to work. This particular, most of trigonometry only works in right triangles. At least in the beginning, as we start, this is called right triangle trig. So, of course, there's a right angle in it, and there's another angle. You could find this angle using triangle sum theorem, and you could use that angle to solve the problem. That's not illegal, and actually, it sometimes makes problems easier to avoid the variable in the denominator, for example. So we will fine-tune what we do, but for right now, or to make it easy, we're just going to stick with the angle that they gave us, okay? So, according to this 54-degree angle, right, what does step 1 say? It says mark H, O, and A. Okay, so H is across from the right angle. That's H. There it is. O is this. That's across from the 54, right, across from the 54. And, of course, A is right next to the 54-degree angle. So that's A, right? X is the opposite. I hate to say equals because it's really not equals, but it is the opposite leg and it is the adjacent leg, right? So I'm not going to put equals there. I'm not really fond of that. So I'm just going to say this is the opposite and this is the adjacent. Okay, so what do I want to do, right? Find out what you know and which side you want. Which side you know and which side you want. So, right, I know the adjacent and I want the opposite. Nobody asked me to find the hypotenuse here, right? They want the opposite. So what has O and A in it? Go look at SOH-CAH-TOA. Pause the video if you're totally lost here or you're just learning this. Go look at the video. Pause the video, excuse me, and go look at your trig equation, your SOH-CAH-TOA, and see which one has OA, right? All right, and I think by now, if you pause the video and you restart it, you know that that's tangent. So tangent of the angle, that's 54 degrees, equals the opposite over the adjacent. Okay, there it is. Now, be careful. We're going to solve this problem. You need your calculator. So a couple of things. Make sure you're in degrees. Make sure you're in degrees. If you're in radians, you're going to have a problem. So you press mode and scroll down 3 times and then move over to the, I think the right is degrees. But anyway, just make sure you're in degrees by pressing mode and scrolling down 3 times, or twice, scroll down twice, 3rd line. Hopefully your teacher went over that with you. I'm sure they did. Okay, now you can plug the number in for tangent of 54 right here if you want to, okay? And get the decimal value, all right? And then multiply both sides by 5. I'm trying to get x by itself, just like in regular algebra. But what it's more convenient to do usually, so you can do it in one keystroke, is multiply both sides by 5 right away. Now the only problem with that is, and I'm going to show you what not to do, right? Don't do this, not to do. But I saw many of you doing this. This is what I got. And it's a very common and understandable mistake when you first start, okay? See, they multiplied both sides by 5. You can't do this, right? That's like breaking into, that's like sort of saying square root of 4 times 3, okay? And saying, oh, well, that's just square root of 12. I could just break into the square root and make that square root of 12. You know this is equal to 6. This is not equal to 6, okay? So you can't do that, right? You can't do that. So same thing here. Very bad thing to do. Instead, move the 5 to the front of the equation, always in front of the trig equation. So I'm going to put 5 over 1 here. Of course, you don't need a fraction over there, and 5 over 1 here. I'm multiplying both sides of the equation by 5. The 5s reduce out. Okay? I really shouldn't put this in my answer slot because we're going to put our answer there. Whoops. Sorry about that. Let's see if I can move this down here. Okay. Okay, and we did the not to do's fine, so we don't have to do that. So I'm going to move everything down here. Okay. And that's it. And then, of course, you got to put in your calculator. Okay, so these 5s reduce to 1 over 1. You get 5 times, right? I like to put a little dot there. You don't have to. I don't need the over 1. Or you could use parentheses if you want. Parentheses just get a little cumbersome because there's double parentheses, right? But it's true. It's fine. You can do this. Equals x. Okay? So you're going to put that in your calculator, and you're going to solve that. Okay? I'm going to do that at the end, so I'm going to leave that to you. Actually, maybe I'll even leave that for your teachers to give the answer. We'll see. Let's just set up the rest of them, okay? Okay, so again, if you saw what I just did, try it with this problem. Follow the directions at the top of the screen. Okay, so I'll leave those directions up there. Pause the video. Try problem 2 in Notability or on paper. Follow these directions. Watch what I just did again if you need to, and then try that problem. Okay, so hopefully you noticed you have this angle here, and you have the opposite, right? This is the opposite, and you want the adjacent, right? This is h. You don't need that. So again, we're going to use tangent, right? So tangent, I don't want to put that here. That's where the answer goes, right? What you should have is x equals a number here, okay? Okay, so we're going to write tangent of 27, okay, equals opposite over adjacent, okay? Much harder problem than the one we just did, all right? Much harder problem. If you remember what I've said many, many times to you, how to solve problems when x in the denominator, then you won't have a big problem, all right? So it's going to take us 2 steps. You can divide both sides by 5, but you will probably mess it up and make a mistake, right? It's not a good habit to do. You can't divide by x on both sides. That's not going to work, all right? So what you need to do is wherever you have a denominator, you multiply both sides by that denominator to get rid of it, right? Even if it's an x. So we're going to multiply the left side by x and the right side by x, okay? And what's left is just 5 over here, right? These reduce. And what's left over here is x times, right? And maybe I will use parentheses here, tangent of 27. Okay, when you have something multiplied by x, how do you get it by itself? You divide both sides by the tangent of 27 on both sides. Notice you can't divide by just tan. You can't divide by 27, right? This is all one thing. This is an expression. It's some decimal. But in your calculator, you'll see which decimal it is. And finally, this leads to x equals 5 over tangent of 27. Okay? I actually don't have my graphing calculator with me, so what I'm going to do is at the end of the video, or maybe I'll add it during the video. I'll just have call outs. So if you already see the call outs, that's probably what I've already done. Otherwise, you can just put that in your calculator and then put the answer here. Okay, it's just calculator work, but you're going to press 5 divided by tangent of 27, enter, and make sure you are in degrees. Okay, problem 3. Again, if you haven't tried any of these yet, please pause the video, try the problem, and then run the video. Okay, I have 33. Now, in this case, I want 2, so we're going to do one at a time. We'll start with x, okay? And we have 15. So x is the opposite, and 15 is the hypotenuse, and y is the adjacent. So to solve for x, what do I got and what do I want, right? I've got hypotenuse and I want opposite. So that is OH, so that's sine. So I'm going to write the sine of 33 degrees equals the opposite leg over the hypotenuse. I hope you know what you're going to do now. Very simple. We're going to multiply both sides by 15. And that's it. X equals 15 times the sine of 33. Okay, put that in your calculator and then put the answer here. Now for y, right, it's just a separate problem. We'll go down here. I think I have room down here. Okay, now for y, what we're going to do is we're going to have the adjacent, and I know the hypotenuse. Now I know some of my students are saying, wait a minute, I just solved for x. Can I do tangent? You can, but imagine, what happens if you got the x problem wrong or if you rounded it too much, right? So this way you're using a number that you know is right, and you can't propagate that error. You can't use your error to get an error on the second one. So it's better to use y. So we're going to use cosine of 33, right? Because y is the adjacent. So I have the adjacent. I want the adjacent and I have the hypotenuse. So cosine is adjacent over hypotenuse. I'm not going to show the work here. You know what to do. Multiply both sides by 15. Cosine of 33, parentheses would be helpful here, equals y. Throw that in your calculator and get your y equals answer. Okay, and finally in the last problem here, same thing, we want to find x and y. So I'm going to take this one and this one. This is my h. This is my adjacent. This is my opposite. So to solve for x, I want opposite. That's what I want. And what do I got? I've got h. So that's sine, right? Opposite over hypotenuse. So sine of 35 equals x over 22. And cosine of 35 equals y over 22. You know how to solve these both. You multiply both sides by 22 and then put your answers in here. Okay? Okay, so I'll try to add the answers in after I produce the video, but they're very simple. Just put them in your calculator. You should have them already. My students go to Backpack in about an hour. Probably by the time you watch the video, it'll already be up there, and I will be posting a worksheet. Please do that worksheet tonight in case we have school tomorrow, but if it looks like we're not going to have school tomorrow, which you'll know about, I'm sure, later, then it's due on Thursday, okay? Miss Serrano, Miss Grigsby students, you go to your Backpack and you may have a different assignment and work on that sheet, and then that will be due the next day we have class. Okay, guys, I hope this video has been helpful. Of course, email your teacher if you have any major questions, and good luck. We'll see you on Thursday, hopefully.